dissect this. Then I have x into, what is common here? X. I have x minus 2. What is common here? Plus 1. X minus 2 equals to 0. Then what is common here is x minus 2. So I have x into x minus 2, x plus 1 equals to 0. So if you want to interpret this, what it means is that x equals to 0, that's the first one. X minus 2 equals to 0, that's the second one. Then x plus 1 equals to 0. So I have x equals to 0, or this one becomes x equals to 2, or x equals to minus 1. And the question now asks for the positive number of x. You know that x equals to 0 can be minus 0 or plus 0, so we can't pick this. So we come here. This one is a negative. The question never asks for a negative value, rather a positive value. So our answer here will be 2. So we go to our option and click on option C, which is 2. Then the next question is this question. The question says that, remember that part of what we highlighted difference of two squares. Very, very important. Difference of two squares. Difference of two squares. We highlighted difference of two cubes. Difference of two cubes. We also talk about perfect squares. Take note of this aspect. Difference of two squares says that when you have a square minus b square, it's the same thing as saying a minus b into a plus b. So this is all about difference of two squares. Difference of two cubes. When you have a minus b into a square plus ab plus b square is the same thing as saying a cube minus b cube. That's why they call it difference of two cubes. You can see this is a cube, difference minus. Then we also have sum of two cubes. Let me include it here. Sum of two cubes. So that one is saying that a plus b into a square minus ab plus b square. And that is a cube plus b cube. Then perfect squares. A number is said to be a perfect square if the square root of that number gives us an integer. That is a number without a decimal part. Example, 1 square. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So these numbers are perfect squares. But square root of 5 will definitely be a decimal, so it is not a perfect square. This is a perfect square. This is a perfect square. This is a perfect square. So on this note, the question 3 asks us to simplify. So we are asked to simplify 3, 2, 4 minus 4x equals to, I said equals to divided by 2x plus 18. It should be noted that 18 times 18 is 324. That's the first thing we should note. We should also note that 4x squared can be written as 2x all squared, because when these two come on this 2, it becomes 4. When these two come on this x, it becomes x squared. So that means we can write 4x squared as 2x all squared. So I can come here and say 18 and 324 is here 18 squared. And this one is given as what? 2x all squared over 2x minus 18. So now we can apply. Why we need to resort to this? Because I sense that they are trying to apply a principle, and that principle is what? Difference of two squares. Because now you are seeing this square, you are also seeing this square, and there is a difference, that's minus in between them. So what it means is that we come here and say, according to what that principle is stating, so you subtract them, then you add them up. Subtract them, that's 18 minus 2x. Then you add them up, 18 plus 2x over 2x plus 18. So I can restructure this one to look like this. I can have minus 2x plus 18 for this one. Take note, then this one can also be 2x plus 18 over 2x plus 18. So this one can cancel this one. Then I have minus 2x plus 18. Then if you look at this one very well, you discover that is that the answer there? If you look at the correct answers very well, you discover that no one is expressed this way. So but I know that 2 is common to this, so I can bring minus 2 out. When I bring minus 2 out of this, I'll be left with what? X. When I bring 2 out of this one, I'll be left with what? 9. But when I bring minus 2 out, I'll be left with minus 9. Why? So that when I open it up again, the fundamental principle of mathematics is not violated. So let's see, minus 2 times x minus 2x, minus 2 times minus 2 times minus 9, minus times minus plus, 2 times 9, 18. You can see that now. But if I had put plus here, minus times plus will be minus, and the fundamental principle of mathematics will be violated. So that is why on this note, it is pertinent to note that when you have minus outside, then you have a positive here, then that positive must change to minus so that you can, because when you are moving from A to B in mathematics, you should also be able to move back from B to A without violating the fundamental principle. So at the end of the day, my answer is this. So I go to my option and trace the one that correlates with that. Then which one correlates with this? It will definitely be option D. So option D is my answer. Now to question 4, we see that if one factor of this is equal to the other factor is, now look at what you have. That is why, I said earlier, this is testing difference of two cubes, but it takes somebody that has a sound understanding of mathematics to recognize that this is testing for what? Difference of two cubes. How do I know? Look at this. X raised to power 3 minus x raised to power minus 1. By the time I try to restructure this, I'll have x raised to power 3 minus 2 raised to power minus 1, everything affected by 3. So you can see that if you open this one up too, it will be, because 8 raised to power minus 1 is just like saying 2 raised to power 3 raised to power minus 1. So automatically minus 1 times 3, that will be what? Minus 3. So I can write this one. And one thing about mathematics is that when you have 2 raised to power A raised to power B, it can also be 2B raised to power A. They can interchange. Are you getting that now? So that means here you can have this. And when you have this, automatically this is what? Difference of two cubes. And which is stating that what? A cube minus B cube is the same thing as A minus B into A squared plus AB plus B squared. Still remember, then that means I can apply this one as x cubed minus 2 into minus 1 all cubed equals to x minus 2 raised to power minus 1 into x squared. Then you multiply them, so we have plus, that's 2 minus 1x plus 2 minus 1 squared. So which I can simplify as x squared minus x minus 2 raised to power minus 1. And this one is x squared plus 2 raised to power minus 1x. And this one will be plus 2 raised to power minus 2. Or yes, 2 raised to power minus 2, or let's say 2 raised to power 2 into minus 1. Remember I said they can interchange. So you can have something like that. Then at the end of the day, I'm going to have x raised to power minus x minus 2 raised to power minus 1. Then you have x squared plus 2 raised to power minus 1x plus 4 raised to power minus 1. So we go now. Since the question told us that if one of the factor is this, and that's one of the factors, then you look for this other one. So where can you find this other one? In the option. So in the option, we are going to have this one is raised to power 2. So automatically in the option, we are going to have option C as your answer. This option C is written like this, or it can also be written like this. Option C is, look at option C close. That's why when you are doing this, you have to be extra careful. If these options are anything to go by, because option C also has the middle of this is 4 raised to the power minus 1x. So automatically, if you look at this, then you say that no answer correlates to what you have, because this is your result. So in some cases, they might not put the answer there. In other cases, the answer might be there. But in this context, the answer to the question will be x squared plus 2 raised to the power minus 1 x plus 4 raised to the power minus 1, or x minus 2 raised to the power minus 1 into x squared plus 2 raised to the power minus 1 x plus 2 raised to the power minus 1 all squared. So that you have it this way or this way. So that is what you should note. Then the next question, question 5, says that multiply this by this. So in this situation, we have